right, now we're going to move into a series of lightning presentations. Each of these presentations are 5 minutes long. We have 7 of them to come. And so I'm going to be a little bit ruthless on the timekeeping of this one. But first, I would like to introduce in the room, I believe, speaking with us, which is your
Habtom, Kahsay, Gidey. Yeah,
towards cognitive software bots. If you'd please introduce yourself and do your lightning paper. Your takers. Well, there's a bunch of people out there. Okay, over to you. Oh, have you got the microphone? I could have a microphone. Thank you.
Okay. Yeah. So yeah, I'm Habtom, and with my colleagues, we wrote this paper, and I will introduce the paper. I mean, it's lots of details, so I will leave the details for the poster session maybe. And I will discuss quickly, where can I find, yeah, good. So I will discuss quickly the motivation behind and what are the key architectural challenges we found out to be important for cognitive bots on the web. And I will also see a summary and yeah, the main outlook. How can I go forward? Yeah, good. So yeah, the reason behind or the motivation is that digital platforms are growing complex these days, and there is a growing interest to augment them with bots. And these bots are usually expected to be a little bit more intelligent than traditional automation. So in case of like robotic process automation, web of things, also in smart factories, we have this need for augmentation with intelligent bots. And for example, for our case, a scenario could be a user-like bot that accesses a web platform and can autonomously identify its situation there, or it's like what is there, and also be able to recognize key affordances or signifiers in general, understand the whole platform, and be able to do navigate, interact, also behave autonomously on the web in a way. And when I say affordance and signifiers, this could be a good example. The whole idea about affordance comes from Gibson's point of view of perception and vision. And buttons could be as examples of affordances, and the text that follows, or the cue, or the signifier could be the text behind, on top of it. And in general, the application for this area of work could be cognitive automation. Also a good interest could be kind of, they can be seen as experimentation for AGI research also. What kind of hypotheses can we test and continue to modify our models in a way. And yeah, so we did the problematization kind of research. So it's just to identify what assumptions are there today and what alternative assumptions could be drawn also or identified. So the key challenges are the transduction problem, one of them. And this is about the autonomous web navigation in a way, in our context, in our scenario, but it could be any digital platform. It could be digital twins or in a smart factory also. The idea is to enable bots understand and also map their action or translate their action, what they see, what they sense into this, from this web environment in a way. And as I said before, there are current assumptions. For example, the current way to do this could be based on API-based exposure or representing the environment partially in a way. And it could be also knowledge description. In Web of Things, they use kind of what they call thing description. And this is good. It works somehow, but it's not autonomous. And the bots don't have autonomous presence. or agency. They don't have knowledge of their environment, so they are not aware of the, they don't have this situational awareness. They don't have the capability also to understand variability of web affordances in a way. Most of the times they are like GitHub bot or Twitter bot. They are attached to a platform. The new way of approaching this is to use behavioral cloning, but with yeah, bigger platforms. OpenAI uses, I think, the Universe or something. And these are some promising, but there is a huge gap and there is no closeness to a user, a human user in a way. And there are other approaches like to completely shift web platforms into cognifying them or changing them to agent-based programming or botifying them in a way. So these are some of the assumptions in the paper. There is more we can also discuss later. But in general, to maintain or to bring this autonomy, there must be, or to have this agency and separation in a way. So the most recommended ones are like to separate the agent or the bot from the platform or from the web environment. In that way, autonomy can be achieved. And yeah, there are other assumptions as well. So this is the first challenge. The second challenge is the behavior problem. This is a big challenge, but in our context, still in the area of cognitive automation, this is about endowing the bots with complex behavior where they can autonomously operate in web environment in a way. And there are different assumptions, definitely. This depends on the abstraction model. Do we use a brain model or a virtual brain behind, or do we use a cognitive architecture, or do we start from the bottom up? I mean, it's different approaches. I mean, a good example could be like OpenCog, but how do we put this into our context is a big challenge also. So there are alternate assumptions. In the paper, we discuss this and we problematize also in this area. The other challenges are the communication, cooperation, and in general integration. These are the up to 4 challenges. By themselves, I just put them together to minimize the time. So here we are expecting the bot to be not like to use this standard communication language, agent communication languages, but more than that, to have diverse means of communication. Also like to have participation in meetings in case, I mean, it could be more, but like simple like email, and in general conversational capability, blogging, microblogging, and other possibilities as well. For cooperation, yeah, the whole idea is, can we have collective understanding shared with humans as well? Yeah, more than that also, can there be transfer learning also between agents in a way? So this is all that we go through. And I think in terms of communication, use of large language models is more stronger recommendation in a way. But there are also principles for cooperation at early stage, difficult to implement, very hard. But yeah, we also go through these details in the paper. The last one is the 5th challenge, which is about safety, assurance, and compliance of norms with agents. Here, the prospect approach, or I mean, the concerns are real, but it depends also where the bots could be deployed. If they are deployed in a smart factory or critical infrastructure, the level of safety could risk could increase accordingly. But for this, I mean, the general approaches are, as always, ethics by design. And the other are like also to treat bots as humans and then make them comply with norms and policies. And the recommendation by the European Union is to have intervention possibilities also to override both operational capability at each stage, like design, training, and also operational level. So that's it. I guess time is also up. So yeah.
Thank you very much, Habtom. Yeah, we'll do one Q&A session at the end of all 7 lightning papers. We'll get all the speakers on Zoom. Thank you so much for that.
Thank you as well.
Next up, I think we have Nihad Subasic, or Subasic, on electronic education machine AGI-EEdu. Welcome, Nihad. I don't know.
And I have to share. Here we are. Nice. I hope it works. And 5 minutes start now. Thank you. So my name is Nihad Subasic, and I am a teacher here in KTH. ITM on all these. Also, the last one is mechatronic division. And I'll present my work. Actually, it was homework on a course, and I will start with thank you for very nice course, Professor Wang and Dr. Patrick, and Robert is not here, but thank you for him also. It was a very, very good course, and I'll suggest you who didn't attend the course also, it's something what I recommend everybody. And on the end of the course, we write a little paper, and as a teacher, what should I do? I can just write about education, and I choose to write a machine for to use AGI in my courses. I teach electrotechnique on undergraduate courses, and my students, we use Canvas. Here it's in Canvas LMS. It looks like this one, and I put many different formats, also course material in PDF or either MP4 for lectures or even for exercise. You know, in electrotechnique, there are many calculations and many schema, or there are different ways to learn. In Canvas, we have such different format of actually the same material, but I don't have any control over that. So the PDF can be downloaded, and students usually do that. And then I have no idea if they read it, if they use it, if they calculate at home, and so on. And the next step was to make also to just embedded the Möbius software, which is software designed by teachers in Vancouver, in Canada, and then you can make interactive exercise, and you can use it even for examination, which I do. So in the end, I developed 3 different ways to exercise for students, and then 2 ways to examine them. This one is in Lämning, as is Swedish. It's a weekly submission, and the 10 is the examination on the end also. And it's mandatory. These 2 are mandatory, and these 3 are optional. And we have very detailed statistics from Möbius, but we don't have any statistics. Yeah, there is some statistics from Canvas, but Möbius is really detailed, and we could predict actually on this data, big data from Möbius, we could predict the results of students. And I discovered that actually when I just compare the students who were active in Möbius and with the results on the final year examination, and then I realized also we don't need the final examination actually. But on the other hand, there are many students who do not use, they don't like maybe such interactive exercise online. So we need some machine which can which I could put in Canvas, so embedded in Canvas like Möbius is, and this machine, this also electronic education machine, will learn all my teacher as like my assistant. Also, it will be but I will not go outside of GDPR, just to know. Also, we are in UE, and it's terrible with all these. But no, it's not terrible. Sorry for that. So it's needed. We need that. I have nothing against that. But sometimes when we try to tip some technique, also some lawyers at KTH. No, we will not mention them. So I just continue with the technique also. So the education electronic machine is thought to be part of the canvas as well as Möbius. And this machine will also, the EDU, will be like assistant for my students and even assistant for me, just to check how students feel and how they are, how is going on in their courses also, because I would like to achieve 100% pass for all students, if it is possible, actually. And then we put, I wrote these two research questions: how could the AGI be used in the development process in my courses? And the second one is, how could a continuous prediction of student performance during the course? So the main result of all this, if we can get in real time, also during the course, when I see that some students can achieve even more, so the higher results, if machine just tell students do that or do that, and we can, it would be better both for students and for me. And then, yes, you see that the paper I just wrote a little bit about that. Now it's a little bit about NARSI language. We declared all these values from my courses, also all this exercise. It's on logical level 1. We just make a connection for the students, or for course, for everything which is logically depends on each other. Then on the second level, from null 2 to null 4, we connect. We declare, actually, if students read PDF, then we can get information from Canvas or watched video and so on in Canvas. And then this is statistical data from Möbius. It's very detailed, actually. And this, on the higher level of logic 5 to 6, then we connect the students to all these activities like read PDF or watch the videos or do quizzes, then because we cannot control totally, and that means that it's on the higher level. And actually the results can we see here is code when we connect, it's null 1, and here is null 2 to 4, and when we get some results. And then after that, we can ask all these questions about prediction also. Maybe not, we can't maybe ask if students is falling in love, but it's maybe the second section also continues of the development. So it was in 5 minutes, 1 minute more. It's 4 questions. Oh, okay. Oh, then I thank you. There is, I took it seriously, so I have one poster there, and I printed out even my presentation, so they are outsiders. Thank you.
Well, you are going to have.
Oh, thank you.
Thank you so much. And it looks like you're going to have a big crowd for your poster presentation when we finish the presentations here. Thank you, Nihad.
Thank you.
Lovely to meet you. Right, next up, we're going to go into some online. Oh, no, we've got one more here. Lukai. Lukai Lee is going to present to us a vertical horizontal integrated neuro-symbolic framework towards artificial general intelligence. Thank you very much, Lukai. Welcome.
Good afternoon, everyone. My name is Lukai Li. I come from Tsinghua University, Beijing, China. It's my honor to have this opportunity to introduce integrated neurosymbolic frameworks to all of you. First of all, I want to briefly explain what is the neurosymbolic dichotomy. At a cognitive level, human cognition can be closer. Oh, sorry for that. Sorry for that. Can everyone hear me? Oh, okay. First of all, I want to briefly explain what is neurosymbolic dichotomy. At cognitive level, human cognition can be separated into two subsystems. When watching a shocking face, like on the left, we use fast thinking. It's automatic, intuitive, and parallel. And when doing a calculus, we use the slow thinking. It's deliberate, logical, and sequential. Interestingly, at algorithmic level, the dichotomy phenomenon remain the same. As for AI technology, we got neural networks that has similar properties as fast thinking and the symbolic system as slow thinking. So the question is, does the dichotomy phenomenon indicate a principle for building or understanding a general intelligence? To investigate this problem, we got approaches. We adopt the term from Anton Kolonin in his paper in AGI-21, vertical approach and horizontal approach. The vertical approach indicates is about computer science. It uses the methodology of divide and conquer, and it vertically or sequentially combined the network with a symbolic system to get a heterogeneous benefits. And for horizontal approach, it used the comparison. It compared the horizontally compare the biological data with some kind of model. And with similar input and output, we can get some understanding of our brain. So we want to build or develop an integrated framework that keep these two kinds of feature of these two approaches. So the problem is the symbolic system can hardly be directly compared with our brain or biological data. So we should find a network that can do reasoning. We called the work spiking reasoning network because we choose spiking neurons because it's very plausible. And the spiking representation are naturally discrete and can be regarded as a symbol. And next, I'll briefly introduce the philosopher of designing. In phase one, we use common sense knowledge to initialize the network. Includes the neuron and the connection. It got a default structure. And at the second phase, it learned from sensory information. It used Hebbian learning to manipulate its connection and use one-shot learning to recruit new neurons. And for the third phase is do reasoning under the external instruction. The form of the instruction is about a special temporal patterned stimuli. And this network achieves a distributed reasoning process. And the process can be compared with biological data. As for experiments and results, we test our framework on two visual query answering tasks. For the Clever, it's a static image, and for Clever, it's a video. On these two tasks, we got high accuracy, and the central reasoning network show parallel feature and the robust feature. For more detail, please welcome to my poster for more discussion. Thank you very much.
Thank you very much indeed, Lukai. We're now moving into virtual sessions. So next up we have, on relation between facial expressions and emotions, Alexei Samsonovich. And this is my lucky interested face.
Hello, can you hear me?
Yes, we can, Alexei.
Great. So I will be talking about a fundamental question related to representation of emotions on face. First of all, why should we care about emotions? In our project, we study social interactions between humans and virtual actors represented by avatars in virtual reality. And therefore, we need to be able to recognize and to express emotions on face of the avatar. Therefore, we need to know how big is the dimension of the space in which those emotions can exist. Most popular models, so-called dimensional models of emotions, are either 2- or 3-dimensional, as you see. Plutchik's wheel is 2-dimensional, Löwhem cube 3-dimensional, and so on. Currently, popular models WAD and PAD, WAD standing for valence arousal dominance, are 3-dimensional, and the question is, do we need more dimensions to represent complex emotions like shame, resentment, jealousy, and so on? That's an interesting question, and I am not aware of any study that would systematically investigate the number of dimensions which is necessary to represent those emotions, though there are models that use up to 15 dimensions, for example. In our study, we use first, let me state the problem more precisely. So we have emotions, we have facial expressions. Not all facial expressions correspond to emotions. Of course, not all emotions correspond to facial expressions. There are multiple to-one connections from both sides. And speaking more rigorously mathematically, we can write a structure of 2 fiber bundles, if you will, with common base and the mapping between them, such that there is a correspondence between a certain class of facial expressions and emotions. The question is, what is the maximal dimension of X in this diagram? And in order to answer this question, we use electromyographic study in which we record EMG signals from 4 facial muscles using this electroencephalograph. As a stimuli, we present pictures of emotional faces from emotion database, including basic emotions and including also complex emotions. So participants were instructed to replicate the emotional expression on their face. And at the same time, each image was labeled with the word naming this emotion. We used word embedding, an analog of word-to-vec embedding for Russian words, to represent emotions in multidimensional space. And then we computed canonical correlation between representations of emotions in that multidimensional embedding and in EMG signals. The result is interesting because it gives us only 3 significant correlation coefficients for basic emotions, confirming that we only need a 3D model like WAD or PAD to represent basic emotions expressed on the face. Whereas for complex emotions, it appears that we need at least 4 coordinates. All 4 correlation coefficients turned out to be significant. However, I would not claim that this is a rigorous finding. It still needs further verification because there is a potential criticism that I would be happy to discuss when answering questions. The conclusion is that 3-dimensional space is sufficient for representation of facial expressions of basic emotions, and probably at least 4-dimensional space is required for representation of facial expressions of complex emotions. Thank you.
Thank you. Thank you very much indeed, Alexei. And no AGI conference will be complete without a paper from Anton Kolonin. Hi, Anton. Anton is here to talk to us about Adaptive Predictive Portfolio Management Agent. Welcome, Anton.
Hello, do you see my screen now?
We do. We don't see your face. We see your screen.
Yeah, I'm going to present the work that we are doing with Singularity DAO and SingularityNET on adaptive predictive portfolio management agent, which is the way we try to implement narrow artificial general intelligence applied to portfolio management and crypto finance in particular. So the approach that we are following, that we create infrastructure where so-called a controller agent splits its own personality in two different swarms of subpersonalities. On the left, you see the swarm of subpersonalities or dependent agent which operate in the virtual market environment, which we simulate with the stream of market data, and they trade in this virtual environment, and then the controller agent selects the best strategies, and these best strategies are implemented in the swarm of smaller number of single strategy agents, and these single strategy agents are executing these winning strategies against the real marketplace. So the new advance of our work is that we have added price prediction capabilities to it, and we have made it possible to do portfolio optimization along with trading on the fly. So the agent is able, any of these agents in both swarms are able to operate in two-dimensional portfolio space, where the vertical space in portfolio dimension is presented by particular asset or financial instrument, cryptocurrency in our case. And on the other dimension, on horizontal dimension, you can see different strategies and sub-strategies, where some of the strategies may be just hodling money on loan position, and another strategies may be doing market making with limit order book system with different parameters of the spread and cancellation thresholds. So what we are able to do, we are able to experiment with these different adaptive multi-strategy agents running their portfolio management with different hyperparameters, where hyperparameter on the presented plot corresponds to period which is a controller agent uses to evaluate the strategy of subordinate swarms. Like, for example, on the plot here, you can see that on the leftmost, you see that 2 weeks and 1 week period of strategy evaluation makes it possible to get greatest return of investment. So, for example, you can see that if you have the 1 week or 2 week strategy evaluation period, then regardless of any settings, blue bars correspond to positive return and positive alpha about 4%. And if you control this set of assets in your portfolio, like if you consider Bitcoin and Ethereum to be two parts of your portfolio, you can get the returns up to 17% for the same experiment period of 3 months that was used to create this plot. Another feature that we have added to our agent is the price prediction. So we are using the bunch of social media channels. We are using 200 channels from Twitter and Reddit, and for each of the channels we are evaluating different metrics for sentiment, like positive, negative, contradictiveness, overall sentiment, and we use about 16 metrics from the text computed accordingly to the cognitive behavioral schemata used by cognitive behavioral therapies. So we evaluate 16 metrics like mental filtering, emotional reasoning, all those that are used to diagnose particular cognitive distortions. So given this about 4,000 signals, we are able to make somewhat accurate price predictions. On the plot here, you can see that if we use 1 day prediction interval, the predictions are not quite accurate. So the price prediction line in orange is generally following the ground truth price, which is blue. But if we increase the accuracy of price prediction to the bottom, so we are making price predictions on hourly basis, you see that the orange line for predicted price is anticipating the blue plot of the actual price in most of the cases where the price changes are significant. In the result, we are getting the possibility to make efficient market making with significant positive alpha. For example, on the left, you see different experiments run with different hyperparameters for strategy selection. And you see that in half of the hyperparameter setup, we are getting positive return of investment. Green bars are corresponding to the return of investment between 10 and 27%. That's what we can get if we use the price prediction in our agent strategies. On the right, you see that only one hyperparameter setup makes it possible to get positive return of investment around 1.5%, but all other strategies are not capable to do positive return of investment without being able to make the price prediction. So thank you for attention, and stay in touch with news from SingularityDAO and SingularityNET. Thank you.
Thank you very much, Anton. Absolutely super snappy. We're going to do questions all together at the end. So we'll see you at the end of this session, as opposed to the end of the end. Thanks, Anton. Right, next up we have Christina Sarkisyan and Alexandr Korchemnyi on Zoom to talk about evaluation of pre-trained large language models in embodied planning tasks. Hopefully we have Christina here with us.
Hi, everyone.
Hi.
Okay, are we ready to start? Hi, everyone. I'm Alexandr Korchemnyi, and today I'm here with Christina Sarkisyan, and we're excited to present our work, evaluation of pre-trained large language models in embodied planning tasks. LLMs have found applications in embodied AI and robotics. Recent works show that LLMs are effective in generating plans even without feedback from the environment. Our study focuses on the use of publicly available pre-trained LLMs in three modes of operation, namely subtask evaluation mode, full plan generation, and step-by-step plan generation. To facilitate the deployment of agents in real-life situations, a proper benchmark is needed, such as Alfred. Alfred is a benchmark that tests the ability of AI systems to understand and carry out complex tasks based on natural language instructions in visually dynamic environments. Given a task description, the pre-trained LLM is to build a task execution plan, which is a sequence of subtasks. A subtask is a pair of an action and object. To generate a plan, a language model uses an input sequence and generates a corresponding output sequence. However, matching the generated commands with available actions in the environment can be challenging due to issues like using synonyms, incorrect phrasing, lack of structure, and logical connections between actions. Iterative step-by-step plan generation involves comparing subtasks available in the environment with those generated at each step, selecting the closest match. This is done using an embedding function and causing distance to obtain subtask embeddings. The process continues iteratively until a stop sequence is generated, resulting in a feasible plan as all object actions are grounded to the environment. However, this approach can be computationally complex, growing exponentially with increasing numbers of available actions and objects. My colleague Christina Sarkisyan will now continue.
Let us consider the next mode is subtask evaluation mode. In this mode, the LLM is used as a scoring model that predicts the probability distribution over a limited set of subtasks, rather than generates the text auto-regressively. This mode ensures the plan executability due to the model's constrained output. However, it is resource intensive since it requires multiple prompt passes for the model. To speed up the generation process, we've developed a set of rules for the output environment to reduce the number of possible subtasks at each generation step. As LLMs, we consider three publicly available models: The parameters number varies from 6 billion to 30. For the experiments, we chose 3 alphabet task types of different levels of complexity. We conduct 2 blocks of experiments. In the first block, we use task-specific prompts that are individually set for each task type and contain examples of only this type. While for the second block, we use mixed prompts that include examples of all 7 task types. Here is the prompt example that is made in the form of a dialogue between a human and a robot. As you can see, there is the general task description in the beginning of the prompt, followed by several examples of correct plans. Measuring the quality of plan generation may be a challenging task due to the natural language ambiguity and the multimodal nature of the task. That is why we use 3 metrics that evaluate the generated plan and the ground truth in terms of various criteria. We also present the results of human assessment to obtain a detailed analysis of the method's performance. For the experiments with the task-specific prompts, we can see that the sequence of actions is successfully determined in most experiments. That is evidenced by the high action exact match metric. According to human evaluation, our approach with GPT-Neo-X model achieves the best quality of about 83%. For a mixed prompt, the accuracy values have mostly decreased, but for the most complex task type second place, larger models like GPT-Neo-X predict actions better than the smaller model GPT-J. Through the experiments, we have shown that the LLMs with a relatively small number of parameters allows us to generate plans with high accuracy. We've also shown that the number of LLM's parameters in the range from 6 to 30 billion does not affect the quality significantly. For a task-specific prompt, the subtask evaluation mode is the best method, while for a mixed prompt, the step-by-step generation outperforms other methods. Our further work is to study the systems that generate a plan dynamically and receive the feedback from the environment. Thank you for your attention.
Thank you very much. Where's our photographer? Rainer, is he around? Can someone please take a photo? Oh, well, I just like having the women, you know, when we have them. It's only our second one. Did anyone get a photo of Christina? Let's have Christina back on screen. Hi, Christina. Loved your paper. Thank you very much. Someone please take a photo. Thanks. Bart. Thank you. Thank you. Right. Our very last paper of the day is not of this session, is not with us in the room. This is Computing with Categories in Machine Learning by Eli Sennesh, Tom Zhu, and Yoshihiro Maruyama. I'm going to read the abstract to you all. Category theory has been successfully applied in various domains of science, shedding light on universal principles unifying diverse phenomena and thereby enabling knowledge transfer between them. Applications to machine learning have been pursued recently, and yet there is still a gap between abstract mathematical foundations and concrete applications to machine learning tasks. In this paper, we introduce DiscoPyro, sounds like fun, as a categorical structure learning framework which combines categorical structures such as symmetric, monoidal categories and operads with amortized variational inference and can be applied, for example, in program learning for variational autoencoders. We provide both mathematical foundations and concrete applications together with comparison of experimental performance with other models, e.g. Neuro-Symbolic models. We speculate that DiscoPyro could ultimately contribute to the development of artificial general intelligence. Thank you. Thank you, Eli, Tom, and Yoshihiro, who are not here. Right, we're going to do a short Q&A session for those 7 papers.
Hello, I have a question to Christina. Did you consider to fine-tune your models on your specific tasks?
Thank you for your question. I think that it is the direction for further research, but I think it would drastically improve the results because it's a few shot learning, so that is why the accuracy results may be not so good as we would like it to be. So it's for a further research.
Thank you.